Welcome back, students, for the third or the continuation session of competitive MCQs related to HaloAlkanes and then HaloArenes. In the first two different sessions, we have discussed nearly 50 MCQs. Okay, so now we will move on to the MCQ number 51. Which of the following cannot be an inflammable? Means which doesn't catches the fire is called as inflammable. Okay, so here chloroform, benzene, benzyl chloride and then carbon tetrachloride. So here CCl4 is the best example for non-inflammable, or it is cannot be an example for inflammable because it is sold or named under the trade name of pyrene. Pyro means it is called as high temperature, means it can destroy the what? The higher temperature. That is why we can say that it is an example for a what? Non-inflammable, that is CCl4. In addition to that, the another important application of this one is it can also be used as helminicide, means it helps in the preservation of which one? The hookworms. That is another. The main thing is it cannot be an example for an inflammable. Apart from that, it is mentioned under the trade name of pyrene. Along with the another major application related to this one is helminicide, because its main use is concerned on its dipole moment. Because even though CCl4 is an example for aliphatic usually aliphatic compounds when get heated, we are calling that as ignition test. We are getting the smoky or the sooty flame here. But here as it is aliphatic, we should get the non-sooty or non-smoky flame. But here we are getting the sooty or it may be the sooty flame. Why? It depends upon the percentage of the carbon content that has been present relative to the hydrogen. Even though it is aliphatic, but there is an absence of which one? Hydrogen. That is why we can say that it burns with a what? Sooty or it may be the smoky flame. Even though it is an example for a what? Aliphatic. Okay. So let's move on to the MCQ number 52 here. The major product in that particular reaction is, so just I want to write the reactions for that. The first thing is, I will just write the reactant in that. The phenyl or the benzene ring here, methyl group, it is Br, here it is F, here it is NO2. When this reacted with PHSNA in support of a solvent called as DMF. Okay, so here we are having the four different options. The first option is the benzene with same Me, but it is dot with what? SPH along with same F along with NO2. The B option is found to be the same, but with the Me here. But the thing is, here it is SPH along with F and then followed by the same NO. The C option is found to be the same benzene with Me along with the dotted line, not the dotted line here, the perfect line between them or the bond between them, SPH here followed by same, and the last option is Me here. Again, it is a thick line here consisting of, I think, SPH. There also it is substituted with SPH followed by the last one is NO. So here, what is the name of this product now, or what is the major product that has been formed in this particular reaction? So here the thick line shows that it is towards the plane. If it is dotted, if it is behind the plane. That is a three-dimensional structure here. So here methyl, benzene, fluorine, NO2, they are in the planes here. Whereas Br means it is towards the plane because as it is represented in the thick line. Whereas the dotted line what we have mentioned is showing it is beyond that one. Okay. Now, as if we are using the PHSA, that is C6H5O-Na. I think you have heard about that. Sodium phenate. It is sodium phenate. But here, instead of that, if I put S, It is called sodium phenothione, because as if in the previous session what I discussed, OH is a alcohol. If OH is attached to the benzene, that is called as phenol first. Similarly, if SH is the case, it is called as a new functional group called as thiol, or if it is a substituent, it is named as mercapto. But here, as it is a phenolic substituent, therefore it is called as sodium thiophenate. Sodium thiophenate. Here, Na plus and then C6H5 minus, or indirectly we can simply that as, here this is the nucleophile now, pH S-. Okay, so its conjugate is pH-SH. pH-SH. Usually, phenolic substituents are weak acids, as if already we know that. Why phenols are going to be the least acidic? Because they undergo partial ionization, even though the phenoxidine is stabilized by the resonance, and also it doesn't give the brisk effervescence when it is treated with sodium bicarbonate. That is why it is considered to be the what? Weak acid. As it is a weak acid means what is its conjugate? It is a strong base, or we can say that it is a strong nucleophile. What file it is? Strong nucleophile. Because its conjugate as it is weak means its nucleophilicity is going to be the what? Strongest. Apart from that, we are using a solvent. What is it called as? A dimethyl formamide. What's that? Dimethyl formamide. So here, it is an example for an aprotic solvent. Means the solvent which doesn't contain a proton. Doesn't contain a proton. On that basis, it is deciding that it is going to be the what? The aprotic solvent means along with the presence of a strong nucleophile. Strong nucleophile means aprotic solvent means it is non-ionizable. If it is a proton content means it is easily soluble. Whereas as it is an example for a aprotic solvent, it doesn't get soluble. Means it's a non-polar solvent and that is a strong nucleophile. Means there is no process of ionization here. If this be the case, we can prefer it is by what? SN2. Because SN1 is polar solvent, weak nucleophile is sufficient. Whereas SN2 is what? We need a strong nucleophile and there is a presence of a non-polar solvent because we can't expect any ionization. Means what we can expect SN2? Whether it is racemization and inversion. Racemization means I am getting both the D isomer and then the L isomer. Because in case of tertiary butyl bromide SN1, what we have decided, we are getting the mixture of both the D and L of 50-50. That is what is called as racemization. But here SN2 is called as backside attack. Backside attack means it is called as, what is that? Inversion. It is called as inversion. Means where the nucleophile has to be attacked. As it is, I am mentioning that it is a towards a plane means where the nucleophile PHS minus has to be attached to the opposite. What is that opposite here? It is the backward or beyond the plane. Beyond the plane the nucleophile is attached means we have to remove this Br minus and enter by that. Means there are these two are the possibilities here, but these two gets cancelled. Why? Because I am not, Br doesn't replaces here or the replaces, but here it retains. Here we are having the two possibilities of which one? SPH. But the thing is, as it is towards the plane means its opposite is going to be the beyond the plane. Beyond the plane means it is going to be the what? It is A. Because first you have to think of the nucleophile. The nucleophile is what? PHS minus. It is similar to that of phenoxide ion. Phenol is a what acid? Weak acid. Therefore its conjugate is going to be the strong base or the strong nucleophile. And the solvent that we have chosen is an example for aprotic solvent. Aprotic solvent means doesn't have the capacity of ionization. Ionization, no ionization, non-polar solvent along with what? The strong nucleophile means first it have the intimation of what ionization, what mechanism? SN2. And SN2 always refers to what? Inversion. Inversion means if it is towards a plane means the nucleophile has to be entered away from that. Okay. So that is why the 52 is going to be the what? A. Let's move on to the 53 here. The bottle containing C6H5I, that is called as iodobenzene, and then the benzyl iodide lost their original labels. They were labeled as A and B for testing of which and which? For testing. A and B separately taken in the test tube and boiled with NaOH. The end solution in each tube was made acidic with a dilute HNO3, and then some silver nitrate was added. Our solution has been added. Substance B gives the yellow precipitate. Which one of the following statements is found to be the true here? We are having these two. I don't know the name of that. Okay. Both are boiled with which one? NaOH. Both are boiled with NaOH. Then it has been treated with what? HNO3 along with what? AgNO3. We know that silver nitrate is the best example for a precipitating agent if it is an example for a organohalogen compounds. What compounds here? Organohalogen compounds. So here, substance B gives the yellow precipitate. So here it gives the yellow precipitate. What is that yellow precipitate here? Can you say that it is called as Ag? Here it is iodide here, AgI. If it is curdy white, it is chloride. If it is light yellow or pale yellow, means it is silver bromide. If it is a bright yellow, means it is going to be the silver iodide. So here B has given the what? See, yellow precipitate of silver iodide. Means, can I say that no yellow precipitate here? Means it undergo easily the NSR and this no NSR here. Which undergo NSR here? Among this is aryl. C6H5I is called as aryl. Whereas C6H5CH2I is called as R-alkyl. So here it undergo NSR, but here it doesn't, because aryl halides are less reactive towards the NSR. Because they contain a sp2 hybridized carbon, but here it contains a what? sp3. Therefore, which can readily give the precipitate? Means it is only the B has given the yellow precipitate. Means B must be R-alkyl. B must be what? R-alkyl. Therefore, what is? It is aryl. So choose this here. A was C6H5I. A was C6H5I. Sorry. A was C6H5I. A was C6H5CH. So I think first is correct. I think B is not this. Addition of HNO3 was unnecessary. Therefore, A we can choose in the form of what? C6H5I. Okay. So that is a difference in the distinguish test to distinguish between which and which? Aryl halides and then the R-alkyl halides. Okay. So let's move on to the 54 here. Grignard reagents undergoes what? The major applications. Another important thing is all Grignard reagents can involve in the preparation of all the types of functional groups in the organic compounds. They can use in the preparation of haloalkanes or any organohalogen compounds. They can use in the preparation of alcohols, aldehydes, ketones, carboxylic acids, phenols. Everything has been prepared by the one common reagent that is called as the Grignard reagent. Therefore, how they can be prepared by? They can either by the substitution or it may be the which one? Addition. Means this involved in the preparation of all of these. Either they can have the property of undergoing the substitution reaction or it may be the addition reaction. So for example, RMGX when it made to react with water. What's the product here? Here I am getting RH plus MgX with what? OH. Means I have removed which and added with this. This is called substitution. Whereas, what happens when RMGX made to react with either formaldehyde or any other aldehyde or any ketone or solid carbon dioxide? We know that these are the three important concepts where we are using the preparation of primary alcohols, secondary alcohols and then the tertiary alcohols. When Grignard reagent made to react with only formaldehyde, we are getting the formaldehyde. Before that, first it undergo what reaction? Addition reaction. Okay. First it forms an addition product followed by acid hydrolysis to form a respective what alcohol? Primary alcohol. Other than formaldehyde gives secondary alcohol. Whereas ketones gives a what? Tertiary alcohol. Solid carbon dioxide called dry ice, we are getting the carboxylic acids. So those are all the relative properties. Means the major thing is Grignard reagent is used for the preparation of all the families of which compounds? Organic compounds. Okay. Due to either both the, not only by the substitution but also by the which one? Addition. Hence it is both which and which? The A and B. Next is when ethyl iodide and N-propyl iodide, which and which? When ethyl iodide and then the N-propyl iodide are made to react with solid sodium metal in ether, the number of alkanes that could be produced is very simple here, as if in the previous session. Suppose if I use only the what? One type of alkanes, when it made to react with sodium in presence of dry ether, I am getting only one type of alkanes, only one type, higher alkane. Suppose if I have the mixture of which one? HaloAlkanes made to react with same. What is the product here? We are getting RR, RR dash, RR dash, R dash, R dash. Means we are getting the three different types of alkanes if I use the mixture of HaloAlkanes. Means how many alkanes we can expect here? All the three alkanes. Suppose if it is what they have mentioned here, C2H5I and another one is C3H7I. What are the various products here? Eth plus prop gives rise to pent. And within now, eth plus eth is but. Prop plus prop is what? X. So these are the three different alkanes. Or in general, what you have to remember, if I am taking the mixture of two haloalkanes, I am getting how many alkanes? Three alkanes. Suppose if it is only one, means only one higher alkane. That is why it is three alkanes. Isopropyl chloride undergo hydrolysis by dash mechanism. What mechanism it is? So first we have to decide whether isopropyl chloride is a what? Primary or a secondary or a tertiary here. As if I already have mentioned, SN1 refers to the order, what is that? Means this tertiary is highly specific with respect to SN1. Whereas SN2 refers to what? Primary greater than, secondary greater than what? Tertiary. Means primary will have the more importance with respect to which one? The SN2. But here, what isopropyl chloride is? IPC we are calling. Isopropyl means CH3, CH, CH3, Cl. If this be the case, it is directly what? Secondary. Means secondary is middle in both the cases. Means it undergo not only by the SN1 mechanism but also by the SN2. If it is strictly tertiary, it is SN1. If it is primary, it is SN2. But what the isopropyl chloride is secondary. Means it can undergo both which and which reactions? Either SN1 or SN2. Means if this be the case, it is weak nucleophile is sufficient, polar solvent is sufficient, it undergo racemization. When the secondary, if it undergoing a possibility of SN1 means we should use only the what nucleophile? Weak nucleophile and the presence of a polar solvent and then the racemization. What is this? The same isopropyl undergo not only the SN1 but also the what? SN2. If it is a what nucleophile? Strong nucleophile. Then there is no need of ionization. That is why it is non-polar solvent. And then it undergo only one product, that is called as what? Inversion. Means isopropyl chloride being the secondary haloalkane, it undergo both which and which reaction? The SN1 along with what? SN2 reactions. Let us now move on to the 57th here. The name of the product obtained by the addition of HI to propene in presence of peroxide catalyst. Don't get confused. In the previous MCQs, I already discussed that. Peroxide immediately referred, we are calling that as anti-Markovnikov rule if and only if it is HBr. If and only it is HBr. HBr peroxide means it is called as anti-Markovnikov. But here, they have used the what? HI. HI in presence of peroxide is again what rule? Markovnikov rule. When only the anti-Markovnikov? HBr with which as a catalyst? Peroxide as a catalyst means it is called as AMR. That is anti-Markovnikov rule. But here HI we have taken, we are calling that as only the Markovnikov rule. Why you have mentioned that has been discussed in the previous session, that is HI and HCl both are exothermic. That is why HI means even in the presence of peroxide it undergo what reaction? It undergo what reaction here? The Markovnikov rule. So according to the Markovnikov rule, what is that product here? according to the Markovnikov rule, negative least, positive most hydrogens. This is a simple statement. Negative least, positive most. So here, the product, reactant here, propene made to react with what? HI. Even in presence of what? Peroxide. But it is an example for a MR. This is a positive part and negative part here. I minus is a negative. I minus is a negative means it should be attached to the least. Which is the least here? CH or CH2? CH. Therefore it is. Means it is 2-iodopropane. Even though we are using a what catalyst? Peroxide catalyst. It is not the anti-Markovnikov product. It is only the what? Markovnikov product. Okay. So that is 57 in the form of 2-iodopropane. Okay. Let's move to the 58 here. In the addition of HBr to propene in absence of a peroxide, the first step involves the what? What the first step involves? Peroxide or peroxide here, HBr. Means it is nothing but a what? So in absence of a peroxide, it is again what rule? Markovnikov rule. So I think the three different steps we are having. Generation of electrophile, electrophilic attack, and then the nucleophilic attack. These are the three different steps involved in the mechanism of what to what? Double bond with HX to form haloalkanes. Means alkenes made to react with what? HX. The first step is usually the generation. Means it already converted into what and what? The most important step is this one. Means which is the electrophile in this case? This is the electrophile in case of HX or HI. It is H plus. Because this forms an important CC. What is CC? Carbocation. First step involves the attack of an electrophile called as H plus to the alkene molecule to form a carbocation, where we are considering the more stability of that. After that, there is an attackment of the third step is called as nucleophilic. So here, in case of this one, even in absence of a peroxide, means it is the what? H plus. Okay. Suppose HBr, if it is in presence of a peroxide, here it is called as AMR. What's that? AMR. Here it is done by what mechanism? Free radical mechanism. If it is in presence of what? Peroxide with HBr, it is undergoing an anti-Markovnikov. That is why it is preferring the what? Free radical mechanism. So here, if this be the case, it is the free radical that has been attached is found to be the Br dot. So be careful there. If it is anti-Markovnikov means HBr in presence of peroxide, here the intermediate or the first step that has been involved is the attack of the free radical in the form of Br dot. Whereas if it is as usual the Markovnikov rule, the electrophilic attack is very important. Here the electrophile is found to be the what plus? H plus. Identify the set of reagents X and Y in the following set of transformations. So what that X and Y refers to? What is the transformation here? CH3, CH2, CH2Br, it is converted to product. This is converted to CH3, CHBr, CH3. This is carried out in presence of, I think, X, here it is Y. So this is called 1 BP and this is called as 2 BP. What's BP here? Bromopropane. 1 bromopropane and 2 bromopropane. We are converting 1 bromopropane into 2 bromopropane directly or indirectly here? Indirectly. Can I say that first these two are isomers? Preferably they are the what isomers? Position isomers. Which what the possibility that we can have? We have to maintain the same formula. Just to remove HBr and add HBr. That's it. That's a complete. What happens when it undergo removal of HBr? It is called as a DHH. What is DHH? Dehydrohalogenation. Means removal of bromide first and from the adjacent carbon atom we have to remove this. Therefore, I am getting the intermediate as Propene. After DHH, it's undergo dehydrohalogenation to form what in? Propene. What happens when I add now? I am not getting the 1-bromopropane, I am getting the 2-bromopropane. According to MR, what is MR? Markovnikov rule. Means the intermediate is what? Propene. If I remove the HBr, I am getting the 1-bromopropane. If I add that one, we are getting the what? 2-bromopropane. So therefore, which is the best example for this one? It is aqueous or alcoholic KOH. Alcoholic KOH, the best example. Okay. So here, this is deleted here, this is deleted here. Why? Because they are dilute NaOH. Dilute NaOH means they form respective alcohols but not the alkanes. Means I can have either X, B or C now. Either it is concentrated alcoholic NaOH or concentrated alcohol. I can have the two. But what is Y there? It is Y is strictly the HBr. Here HBr is there, here it is Br2. Therefore I can opt this as this but not this. Means first it undergo what? Dehydrohalogenation using concentrated aqueous or alcoholic here. Alcoholic NaOH, and then we have to add the what? HBr in presence of an acidic medium called as acetic acid. Therefore it is 59 in the form of B. Okay. Let's move to the 60 here. The reactivity order of halides for the DHH, already in the previous session I already mentioned. For various haloalkanes, the order is like this. For this one, Ri is always greater than, Rbr is always greater than, Rcl is always greater than Rf. Why? Because this is weak bond. Ci bond is weak. Rf bond is strong. Therefore, the reactivity order is found to be the what? I greater than, Br greater than, Cl greater than F. Where it is? B. Okay. The reactivity order with respect to any reaction, either it is an elimination reaction or it may be the nucleophilic substitution reactions, whatever it may be, the order is what? Iodides are always compared to reactive compared to that of bromides or chlorides, or it may be the fluorides. So hence it is 60B. SN1 reaction is favored. What reaction it is? SN1 reaction. Already I have mentioned now. SN1 means ionization has to take place. Ionization means we should need only the polar solvent but not the non-polar. Therefore, non-polar solvent is not correct. Crowding at alpha carbon, because as if SN1 means it is the tertiary first. As it tertiary means the large number of alkyl groups has been present around the carbon. Therefore, there is a crowding. I think it may be the possibility here. So third one is small groups on the carbon attached. Smaller the groups means it is only the primary. Larger the groups means it is called as tertiary. Therefore, it doesn't have this one also. Hence the option is found to be the what? B. Means crowding refers to what? Tertiary. That's it. Okay. 61 in the form of what? B. Which is the current for the preparation of 2-bromopropane? 2-bromopropane. HBr is treated with 1 propanol. Propanol means CH3, CH2, CH2OH. HBr. The second one is propene. Propene is treated with HBr in presence of peroxide or absence here? Presence of peroxide. 1 propanol, CH3, CH2, CH2OH is treated with concentrated H2SO4. Followed by treating with what? HBr. Then the last one is ethene or ethylene, CH2 double bond CH2. This one treating with Br2 in presence of CCl4. Followed by we are getting one product, followed by elimination with what? HBr minus HBr. So I have to get the what? 2-bromopropane, no doubt. This is the nucleophile here. Sorry, this is the nucleophile that has been removed here. Hence it is this. Hence we are getting CH3, CH2, CH2 with what? Br. Okay. 1 bromopropane, but I have to get only the 2 bromos. I think the first is not possible. Propene is treated with HBr. It is peroxide means Markovnikov or anti-Markovnikov here. It is a in presence of peroxide means it is found to be the what? Peroxide. It is AMR. AMR means negative most, not least. Therefore, CH3, CH2, CH2Br. Again it is 1 bromo, therefore this is also not possible here. 1 propanol treated with constant sulfuric acid. What is the function of sulfuric acid? Dehydrating agent. Means first we have to remove this water OH and then from the adjacent this. I have to get the what? Propene. What happens when propene is treated with HBr? Again, Marconi off, because as if no peroxide is present means it is Marconi off. Negatively is positive most. CHBr, CH3. What this is? 1 bromo or 2 bromo? I think this may be the possibility here. Again, we have to check for the last. What happens when ethylene reacted with bromine? It undergo addition reaction to form 1,2-dibromoethane. 1,2-dibromoethane. Followed by removal of HBr. If I remove the Br from this, I have to get HBr here. If I remove the Br from this and from the adjacent we have to get. Means there is a removal of 2 HBr here. What's the product? CH single bond CH. It is called as acetylene, but not the ethene. Therefore, the preferred product that is called as, what is that? 2-bromopropane is obtained by when 1 propanol first undergo dehydration using concentrated sulfuric acid to form propene, followed by adding with HBr in absence of a peroxide, we are getting 2-bromo what? Propene. Okay. So that is 62 in the form of what? C. Let's move to the 63 here. The major product formed in the following reaction is what? What's the major product that has been formed here? CH3, what is that? CH3 twice means CH3, CH2Br. It is called as isobutyl bromide here. So here, CH3O minus with the CH3OH means, is the nucleophile here? CH3O minus. But as it is in what medium? Aqueous or alcoholic? Alcoholic. Alcoholic means it has to undergo DHH. What is DHH? Dehydrohalogenation. Suppose if it is as usual, the same thing, we can directly mention that as the nucleophile. But as if I am taking the alcoholic solution of that one, means it is not the nucleophilic substitution reaction, but it undergo what? DHH. Means DHH means removal of first bromine from the same or the adjacent carbon atom. I have to remove the hydrogen minus HBr. What's the product here? CH3, CCH3. HBr is removed means there is a formation of a double bond between them. What this is called? 2-methyl propene. 2-methyl propene. Or I can write that in the form of isobutylene. It is called as isobutylene. Isobutylene formula is CH3 twice C double bond CH2. Hence it is going to be the, okay. Suppose if it is aqueous means, if it is the aqueous, the product is this one. Sorry, the product is, I think this. When it is, if it is aqueous, but as if it is alcohol that has been used, methyl alcohol means instead of nucleophilic substitution reaction, it undergo what? Dehydrohalogenation to form isobutylene having the formula CH3 twice C double bond CH2. Okay. Gem dihalides on hydrolysis gives what? What are first gem dihalides? If the two halogens attach to the same carbon atom, it is called as a gem. If they are attached to the adjacent means it is called as what? The vicinal. So here what they have mentioned, gem dihalides are CHXX. What is this called? Gem. This on hydrolysis. Hydrolysis means we have to use the aqueous NaOH. As if there we are having a 2 here. Or CH, OH, OH. But these type of compounds are highly unstable. Why? Any carbon which is surrounded by 2 or more OH groups are highly unstable. That is why they readily undergo dehydration with the removal of water to form RCH. RCH means I can expect first RD8. Not only this, what this is now, this is also geminal. Why? Because they has been attached to the same carbon atom. Again, when it mean to react with same RCOH, OH R dash. Again, this is unstable. Why? Carbon surrounded by 2 OH are highly unstable. That is why here there is a removal of OH and here there is a removal of this to form RCOR dash. What this is? Ketone. Means I am getting both of which are which? Aldehydes along with ketones. Suppose if this is the case, it is called vicinal dihalides. When they are made to react with 2 times of NaOH, I am getting RCH, OH, CH2OH. But this is stable. Why? Carbon is surrounded by only 1 OH and these are called as glycols. Gem dihalides on hydrolysis gives either the which are which? Aldehydes are ketones. Whereas the vicinal dihalides on hydrolysis with aqueous NaOH or KOH gives respective which one? A dihydric alcohol is called as alcohols. So here it is 64 in the form of C. Let's have the 65 here. Which of the following is expected to decompose on standing in the presence of sunlight? So as if already I have mentioned the reactivity order. What's the reactivity order there? Which is more reactive? Ri is more reactive compared to that of RBr is more reactive compared to that of RCl is more reactive compared to that of which one? So here more reactive means it is a weak bond. It's a what bond? Weak bond. So that it readily convert to RR plus iodine. Means they readily undergo decomposition even in presence of what? Light? Sunlight. That shows that it is absorbed in the form of which one? Violet. That is why RIs are always kept in amber colored bottles. Why? Even in presence of a diffuse sunlight, what happens? They will start to get decomposed because the bond between the R and I or C and I is found to be very, very weak. They readily get decomposed with the liberation of which one? Iodine. But what is this? Least reactive. What is the meaning of least reactive? Means CF bond is strong. Means it is found to be the stable. Means no decomposition. No decomposition. So here it is a general concept I have mentioned here. Which of the following is expected to decompose on standing? Means a decomposition is in case of iodides. Where is that iodide? Here it is in the C. Okay. Identify Z in the following sequence of the reaction here. What that Z is? Ethyl bromide CH3CH2Br with alcoholic KOH. What is the function of alcoholic KOH? Dehydrohalogenation. Alcoholic means it is the dehydrohalogenation. Therefore, what happens when ethyl bromide, I think, when they made to react with alcoholic KOH, it undergoes DHH. What is DHH? Dehydrohalogenation. DHH means minus HBr. I am getting first an intermediate as ET. This is called X. This on reading with bromine, as usual I have mentioned right now. Br, CH2, CH2, Br. Ethylene dibromide. This is your Y, I think. This on reading with what? KCN. What happens when haloalkanes react with KCN? They form whether cyanides or isocyanides here? Only the cyanides. That is why CH2, CN, CH2, CN. Means what must be the product here? It is CN. At the terminal ends, we are having the 2 cyanides groups and we are having at the middle, that is the ethylene group. Hence, it is found to be the first is not possible, therefore it is B. 66 is B. Okay. The product obtained on the reaction of ethyl chloride with hydrogen over the palladium carbon is what? What is the function of hydrogen in presence of palladium here? RH is converted to RH. Means haloalkanes are converted into alkanes. How? By reduction. What are the reducing agents we can prefer? Lithium aluminum hydride R. Zinc in HCl R. Sodium in alcohol R. Hydrogen in presence of palladium, or it may be the platinum supported with carbon. What these are? They are the examples for what? RAs. What is RAs? Reducing agents. Any haloalkanes are respectively converted into what? Alkanes. So here, ethyl chloride means what is the product? Haloalkanes or alkyl chloride means alkanes means ethyl chloride means put R is equal to C to H5 here. Here C to H5. C to H5 with H is called as. Indirectly it is a reduction of haloalkanes to respective alkene. An organic compound C4H9Cl, it is indirectly the butyl chloride. Upon Wood's reaction, by monochlorination gives only one chloro derivative. What that compound is, means what type of butyl chloride it is. Means I have to get only the what? One monochloro substitution product here. What are the various butyl chlorides we are having? In the previous session I discussed. One is CH3, CH2, 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 Cl. The second one is CH3, CH, CH3, CH2, Cl. The third one is CH3, CH2, CH, CH3, Cl. This is third one. Last one is. So here C4H9Cl called as butyl chloride can be of four types called as N-butyl chloride, isobutyl chloride, secondary butyl chloride, and then the tertiary butyl chloride. So as it is a Wood's reaction means we have to take which? Sodium in dry ether. According to this, as if we are taking the similar, I am getting the higher alkane of the type, what is that? RR. Means this is R here in this case. Here, this is the R1. This is R here. This is also R. Therefore, the products I can expect is CH3, CH2, 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 CH3. Here it is CH3, CH, CH3, CH2. Single bond CH2, CH, single bond CH3, CH3. And in the third case, I am expecting CH3, CH2, CH, CH3, CH, CH, 2CH3, and finally we are having CH3C, CH3, CH3, followed by same CH3, CH3, CH3. So these are the Wood's reaction products by the four different butyl chlorides called N, iso, secondary and tertiary. So here observing that this carbon atom is different from this one. As if I have mentioned, if it is containing N different types of hydrogen atoms, then we are expecting N number of mono-substituted compounds we can expect. So just by simulating all those, we can decide these three and these three will have the same hydrogen atoms. Therefore, I can expect only one mono-substituted chloro derivative when it is applied with the what reaction? The Wood's reaction. That is why the mono-substituted with only one chloro derivative is observed in case of only the what? The tertiary butyl bromide. Okay. So that's about the 68th here. Next we will move on to the 69th here. That is propyl chloride, N-propyl chloride on treating with alcoholic KOH gives rise to B, B on treating with HBr gives rise to C, C on treating with sodium in dry ether. We are getting D. Then what that D is? So as usual, alcoholic KOH means it is nothing but a what? The DHH. DHH means a dehydrohalogenation. That is CH3, CH2, CH2, Cl with alcoholic KOH. The function of this one is called as a dehydrohalogenating agent, means minus HCl. Removal of Cl, and from the adjacent we have to remove the hydrogen. Therefore, I am getting the CH3, CH double bond CH. This is called as B here. Propene. This on treating with what? HBr. HBr without the peroxide means it is called as a Markovnikov rule. Therefore, negative least. Negative least means the Br has to be attached to the what? This one. Or I can mention this in the form of CH3, CH, CH3 with what? Br. This on treating with what? Sodium in dry ether. It is nothing but the what reaction? Woods reaction, which is of the form RR. What's the R group here? This. Therefore, CH3, CH, CH3 is one side and another is same CH, CH3 with what? CH3. The name of this one is found to be the root word is what? Bute. Butane with the 2 methyl, that is at the positions of second and third, that is what is called as 2, 3 dimethyl, which one? Butane. And the common name for this one is also called as diisopropyl compound, because we are having how many isopropyl groups here? 2. That is why this the 2,3 dimethyl butane is also called as what? The diisopropyl. Okay. Let's have the 70th here. Which of the following nucleophile favors the what? SN2 mechanism. SN2 means it is called as two-step mechanism where the nucleophile must be very, very strong here. So we are having the what? SN2 means first we have to know it is two-step mechanism is concerned with weak nucleophile. Okay? And also it is due to the inversion also. What are the nucleophiles here? OH minus, H2O, NH3 followed by what? OR minus. Okay? So here I am deleting these two. Why? Because we need the strong nucleophiles. According to that, already there is a presence of a negative charge on OH minus and OR minus. That is why these are found to be the strong nucleophiles. Therefore, I am deleting what? This one. Even though they are found to be the nucleophiles, called as neutral nucleophiles they are. Neutral nucleophiles, which are also called as Lewis bases, we are calling. Lewis bases. But that doesn't have any charge. That is why we can say that these are found to be the less nucleophilic compared to that of either which or which, OH minus or it may be the OR minus. And the conjugate of this one is found to be the H2 and the conjugate of this one is found to be the alcohol. Conjugate means the difference in the 1H plus. So here it gets ionized. It's a very, very weak electrolyte here. Why? Because its degree of dissociation is just only 10 to the power of minus 7. But here little bit stronger electrolyte compared to that of which one? The water. Therefore, as it is strong means this is weak nucleophile. As it is weak means it is found to be the strong nucleophile. Because as SN2 refers to the strong nucleophile means we can use the strong nucleophile and that strong nucleophile is in the form of what? OH minus. That is 70A. 71. SN1 reactions is favored by, it's a well-known fact. SN1 means it has to undergo ionization. Ionization needs the what solvent? Polar solvent. Yes, okay. Large number of alkyl groups on the carbocation. We know that the order for SN1 is found to be the tertiary greater than secondary greater than primary. That is why larger groups means it is indirectly called as what? Tertiary. Yes, that is also okay. And then as if we need what the strong nucleophile or the strong concentration of nucleophile in case of SN1 means what is SN2 means what is SN1? It is having the weak nucleophile or it may be the lower concentration. As if be the case, all are the conditions to exhibit the SN1 favorism or mechanism. Next is the formation of a diphenyl by heating iodobenzene with copper powder is an example for a what reaction? Whether it is a Fittig reaction or a Sandmeyer's reaction or Friedel-Crepes or it may be the Ullmann's reaction. 2RX sodium dry ether RR. This is called as Woods reaction. What is that? Woods reaction. Instead of this, if I take zinc means I have mentioned in the previous session that is a Frankland's reaction. Okay. Similarly, 2 times of C6H5X made to react with same sodium in dry ether, we are getting C6H5, C6H5. This is called as diphenyl or biphenyl and the name of the reaction is called as Fittig reaction. Okay. But instead, if I use the copper powder, there also we are getting this, instead of 2NaX, here I am getting the COH2, cupric halide. Therefore, that type of reaction is called as Ullmann's reaction. In case of Wood's reaction, if the sodium is replaced by zinc, the name of that reaction is called as Frankland's reaction. Whereas in case of the Fittig reaction, where the sodium is replaced by copper, the product is same and the name of that reaction is going to be the what? Ullmann's reaction. Okay, so that is 72 in the form of D. Let's have the 72 here. A silver salt of the fatty acid on heating with alkyl halide gives RCOO Ag. Because RCOH is called as fatty acid or the carboxylic acid, H replaced by sodium is, silver is called silver salt of fatty acid. When it is made to react with R-X, that is called as alkyl halide, there is a removal of precipitate in the form of AgX. Now I left with what? Only the RCOO with what? R-. It is called as ester. Means when any silver salt of fatty acid made to react with haloalkane called as alkyl halide, they form a respective which one? Ester. As usual, we have mentioned, if it is sodium alkoxide, the product is going to be the ROR-. It is called as a WES. It is called as Williamson's ether synthesis. If I use a silver salt of fatty acid, the product is ester. If I get the sodium alkoxide, the product is going to be the ether and the name of the reaction is called as Williamson's ether synthesis. So here it is, silver salt means it is the ester. Next is ethylene dichloride and ethylidene chloride are isomeric compounds. Identify the statement which is applicable, which is not applicable to both of them. So first, RCHX2, RCHXCH2X. This is called as geminal and this is called as vicinal dihalides. And the name of this one is called as alkylidene halides. And this is called as alkylene dihalides. Okay, so here this is correct first. Why? Both are what halides? Dihalides. Okay, then they respond to the Bilstein test. What is the Bilstein test? If any organic compound containing what atom? Halogen. When it is ignited with the help of copper wire, suppose if you are getting the green edged flame, then that detects there is a presence of halogen in the given which compound? Organic compound. And that test is called as what? Bilstein test. When any organic sample, when it is just heated in support of what? A copper wire, the formation of a green edged flame indicates the presence of halogen in the given organic compound, and that test is called as what? The Bilstein test. So therefore that is also right here. Next is both react with alcoholic KOH. So first, what is that? Ethylene dichloride. Ethylene dichloride is ClCH2CH2Cl, and another one is CH3CHCl2. This is called ethylene dichloride and this is called as ethylidene chloride. What happens when they made to react with which one? Alcoholic KOH. Alcoholic KOH. What is the function of alcoholic KOH? It is DHH, dehydrohalogenation. Removal of chlorine followed by adjacent removal of hydrogen. Removal of chlorine and followed by adjacent removal means there is a complete removal of 2 times of what? HCl. The product is one molecule results in alkane, whereas the 2 molecules of HCl removals in the form of alkyne. So here also the same thing, I think. One Cl has been removed, one hydrogen has been removed. Another Cl has been removed and another hydrogen has been. So therefore the product is, they react with alcoholic KOH, means both react with what? Alcoholic KOH. Therefore that is also correct. Then which is not correct here? It is nothing but the C. Why it is? What happens when this made to react with what KOH here? Aqueous KOH. Aqueous KOH. So here Cl is replaced by OH. It is called as ethylene glycol because dihydroxy groups with respect to the organic compounds are called glycols. So what happens when the same made to react with aqueous KOH here? CH3CH, OH with OH. But these type of compounds are highly what? Unstable, because any carbon surrounded by 2 or more OH groups are unstable. That is why they readily loses a molecule of which one? Water to form CH3CH. This is called acetaldehyde. Here it forms ethylene glycol, whereas this forms acetaldehyde. But in the option C, what they have mentioned, they react with aqueous KOH and they give the what product? Same product. No, it is not the same product, it is the different product. Therefore, the option for 74 is going to be the what? Because he has mentioned which is what correct? Not correct. Hence, it is 74 is going to be the C. Okay. Let's have the 75 here. Acetonitrile is prepared by treating an alcoholic solution of methyl iodide with a very easiest here. First, you have to know the formula for acetonitrile. What is acetonitrile? CH3CN is called acetonitrile, which is also called as methyl cyanide, or sometimes it is also called as IUPAC enemies. Ethane nitrile. Ethane nitrile. It is obtained from which one? So first I have to write like this. CH3I. What is this? Methyl iodide. How methyl iodide is converted to methyl cyanide? Means we have to remove the what? C, I minus. And instead of that we have to put either KCN or NaCN. Because they are the strong electrolytes. That is why we are expecting the nucleophile in the form of what? Minus Cn minus. Means either I can choose the KCN or it may be the which one? NaCN. Suppose if I use a what? AgCN, the product is isocyanide. But here the cyanide has to be obtained, hence it is not possible. Ammonia, there is no presence of this one. HCN doesn't have that capacity, therefore it is only the what? Either we can choose KCN or it may be the NaCN. But according to this, the 75 is going to be the what? B. Okay. Next is an optically active halide. What's that? Halide, when allowed to react with a Cn minus, gives a racemic mixture. The halide is most likely to be. What that is? Racemic mixture means the process is found to be the what? Racemization. Means we are getting the 50% of what? D isomer and 50% of what? L isomer. The mixture is called as racemic mixture. The process is called as, this is done by what? SN1. What's our order for SN1? It is tertiary greater than secondary greater than which one? Means we have to choose the tertiary halide. Means as if I am getting the racemic mixture, means it is strictly an example for a what halide? Tertiary halide. Allyl bromide and N-propyl bromide. How they can be distinguished here? What's the formula for allyl halide here? Allyl means CH2 double bond CH single bond CH2 group is called as allyl with bromide, and another is N-propyl means straight here CH3 CH2 CH2 Br. Okay, how these two can be distinguished? First is, this is sp2 hybridized carbon, sorry, sp3 hybridized carbon. This is also called as sp3 hybridized. But these two are sp2 unsaturated. This is saturated. All are here saturated. Means it is indirectly the chemical test to distinguish between which and which, saturated and unsaturated. So here one is Bayer's test and another is bromine water test. These are the chemical tests to distinguish between which and which, saturated and unsaturated. If decolorization takes place, it is found to be the unsaturated. If it is no decolorization, means it is saturated. Silver nitrate means it readily reacts with both the sp3 hybridized in the form of CH2Br, CH2Br. Therefore, that is also possible here. Brady's reagent means Bohr's reagent. It is applicable only for the aldehydes and ketones detection. Therefore, that is also ruled out here. Tollens reagent is a chemical test to distinguish between aldehyde and then the ketone. Therefore, these three are not possible here. Hence, we can expect it is the base reagent. What's the base reagent here? Cold, dilute, alkaline, potassium permanganate solution is called as what reagent? Base reagent. It is having a color of what? Dark pink, or sometimes we can say that it is the violet also. If there is a disappearance of a violet color or the pink color, means it is unsaturated. Unsaturation means it is observed in case of allyl chloride, but we are not observing in case of the which one? N-propyl bromide. Hence it is 77 means it is D. Now we will move to the last one. An unknown alkyl halide that is called as A reacts with alcoholic KOH to produce C4H8. Ozonolysis of C4H8 yields only 1 mole of which one? Propionaldehyde and 1 mole of which one? Formaldehyde. Therefore, what that compound must be? So, in the hydrocarbon concept, I have expressed the detail about the ozonolysis. Means, any unsaturated component made to react with the first one is ozone, followed by reductive hydrolysis in presence of zinc dust. Hydrolysis in presence of a zinc dust. Just the product I am getting is like this. Means either it may be an aldehyde or it may be the which one? Ketones. I don't know. Suppose if it is at the terminal position, it is called aldehyde. If it is in the non-terminal, it is called as ketone. So means by knowing the products, I can expect the presence of a bond here. So here, the mixture of which and which? Propionaldehyde and then formaldehyde, HCHO. Can I write that HCOH as O double bond C single bond H? Similarly, I can write like this. Okay? So just merge up this. By the removal of this oxygen, I am getting this product. So similarly here, merge these two. CH3, CH2, CH double bond, CH2. This is called as 1-butene. What butene it is? 1-butene. This is having a formula. What is that? C4H8. But this is obtained from alkene. But it has to be obtained from alkyl halide. Here, what is that A is? What that A must be here? So here, this is having a formula of what is that? Alkenes are obtained from haloalkanes or alkyl, means it is by DHH, dehydrohalogenation, by the removal of HBr, I think. HBr. So here we are having the two possibilities. What is that? One is CH3, CH2, CH2, CH2Cl, or Br here. Or we can have CH3, CH2, CHBr, CH2. There are two different possibilities here. Either we can have the bromine in the first position of butane or second position of butane. Let's try that. Br from this and from the adjacent we have to get this. Means where the double bond has to be present at the first position. Therefore, it is the product. Suppose if this be the case, we have to remove the what? Bromine. From the adjacent carbon atom, among the two adjacent carbon atoms, one is CH3, another is CH3. We have to remove according to the Sedgwick rule, the least. Therefore, the product is found to be the CH3, CH double bond CH, CH3. It is called as 2-butene here. Because according to the propionaldehyde and formaldehyde formation, it is only the 1-butene but not the 2-butene. Means 1-butene is obtained from CH3, CH2, CH2, CH2 what? Br. Therefore, it is found to be the Suppose if this be the case, what are the products here? Just break it. Put the O. Put the O. What is this? Acetaldehyde. What is this? This is also acetaldehyde. Means if I having the what? 2 molecules of acetaldehyde, the product is what butene? 2-butene, and the compound of the alkyl halide is going to be the 2-bromo-butane but not the 1-bromo. But as if I am getting the mixture of what and what? Propionaldehyde and then the formaldehyde. I am getting the product of first as the ozonolysis before product is going to be the 1-butane, and then 1-butane is obtained only from the 1BP. What is that 1BP? Sorry, 1BB here. What is that 1BB? 1-bromo-butane but not from the 2-bromo-butane. So that is about the 78 in the form of what? A. So I think this totally completes the haloalkanes and then the haloarenes, but in general that I have discussed in the form of not strictly for haloalkanes and haloarenes, but I have discussed in the form of organohalogen compounds, because I have discussed that in the form of 2 major types. One is called as aliphatic halides and then aromatic halides. And again, these are of 3 types I have discussed. What is that? One is alkyl halides, alkenyl halides, and then the alkynyl halides. In this case, we are having the two called as aryl halides and then the R-alkyl halides. So in case of allyl or vinyl, we are discussing the form of alkenyl. This is the major concept. Aryl and R-alkyl we are expressed, but we are having a less concentration for the which one? The alkynyl halides. But as far as the syllabus is concerned, no doubt it is what? Alkyl and then only the what? Aryl. But we can't restrict only for these alkyl and aryl, because we are having the Woods reaction in the form of R-alkyl called as benzyl chloride. That is why we are concentrating the 5 different organohalogen compounds called alkyl, alkenyl, alkynyl, aryl and then the R-alkyl. Okay. So I think this completes the whole of the first organic part of the second PU section, that is called as HaloAlkanes and then the HaloArenes. Okay. So and also in addition to that, we have to go through the assignment questions that has been provided for you. Okay. So by remembering all the concept what we have discussed, means from the very highest to the what lowest, means I have discussed the very descriptive form also, that may be asked in the form of JEE mains as well as sometimes it may be the advanced also. But the thing is, this, as far as the CET is concerned, we are having a little bit the easier questions. I have discussed all the types of the MCQs that has been provided for both the HaloAlkanes and then the HaloAlkanes. So, thank you students.